Okay, good. I got Tiara. Maybe audio. I got Deborah. I got Deborah back. I got Tiara back. Okay. Let me share my screen again. Hang on. Get in here. Come on. Okay. You share. Start sharing.
Follow me on TikTok.
Okay. I'm trying to get my sharing back, guys. Let's see what happens. My meeting should start in a few seconds. That's good to know. So I got everybody back. I'm $15 per month poorer. So y'all remind me at the end of the semester that I need to cut this off. I never want to use it again. And I don't want to pay for it for the rest of my life. which I may do.
They're trying to take your money away.
Oh, Lord. Yeah. We'll see. And y'all, by the way, don't have to join anything because it's all on me. That's good. Okay. Let's see what we got. All right. Let me go back to this problem here. All right. I'm still waiting.
You paid $15 for this?
Hey, no, I got it. Okay. They better never cut me off again. Okay. So, guys, let's look at this. This method, and we'll be done after we finish this one. This method is about integrating things that look like rational functions of sine and cosine. Now, here's what I mean by that. I mean, it's a quotient. Instead of just x's in it, it's got sines and cosines in it. And if it has tangents in it, you're going to want to change them to sines and cosines. Okay. Now, I am not going to tell you how this works or why it works, because that would take me forever, and I'm not going to do it. But I will show you something about the substitution, because you'll know it when you see it. It says, using some trig tricks and half and double angle formulas, we can usually write these things that are in terms of sine and cosine by using some funky substitutions. And here are the funky substitutions. If an integrand is a rational expression in sine and cosine, the following will result in a rational expression in u. In other words, instead of having a sine and a cosine in it, it has just u's, just single variables, which we know how to deal with, and we'll look at that. So here's the substitution. When you see a sine x, you'll put this in. When you see a cosine x, you'll put that in. When you see your dx, you'll put that in. And in the end, when you want to write back in terms of x, what they're letting u be here is tangent of x over 2. And that takes some fancy work to get to that, guys. But you're going to change it all to u's, and then you're going to put that in the place of u. And I feel Dr. Young and I always talk about going to math hell because we tell students, just do it because I said to do it. That's one of those times. This might be my last ticket to math hell, whatever. Anyway, instead of telling you why it's working, but this will work. So here's what I want to do. I'm going to take, here are the substitutions. I'm going to take this one right here, and in the place of dx, I'm going to put 2 over 1 plus u squared du. There was the substitution right there. Okay. In the place of sine x, I'm going to put 2u over 1 plus u squared. So the 4 was already there, so there's the 2u over 1 plus u squared. In the place of cosine, I'm going to put 1 minus u squared over 1 plus u squared. Now, so I'm just going to plug those things in that I suggested to you. This is one of those miscellaneous substitutions, and see how it works. Now, that's not pretty. This thing right here is ugly. It is known as a complex fraction. But the nice thing about it is, every one of those fractions has the same denominator. And what's the denominator in every one of those fractions?
1 plus u squared.
1 plus u squared. So here's what I'm going to do to make it look better. I'm going to multiply the top by 1 plus u squared and the bottom by 1 plus u squared. And that's guys, that's multiplying by a disguised 1. Shoot. It doesn't look too good, but you see 1 plus u squared over 1 plus u squared is 1. I'm just changing the form. See the algebra there? I think with you guys that I had in Math 20, we called it complex fractions. I'm showing you a simple way to do it. All right, so here's what we're gonna do. When we multiply 1 plus u squared times the top, tell me what's left.
2.
Tell me what's left when we multiply 1 plus u squared times 2 over 1 plus u squared.
2.
Just 2.
Oh.
See, it made it nice. And now what's left when I multiply 1 plus u squared times this one? What cancels out again?
The bottom.
1 plus u squared, and I have 4 times 2u is 8u. How about 1 plus u squared times this thing? It's going to be what?
-3.
Minus 3 times 1 minus u squared because that canceled that one out. Okay. All right. Does everybody see what I did? It's looking a lot better. All right. Let me scroll up a little bit. I think I may have something written down here. Yeah. Look at. I have that written down here. Now, what I can do is multiply this all out, and I'll go ahead and do that. I already did it. Whoops. I already did it down here. So that's 2 minus a minus is 3u squared plus 8u, and then minus 3 times 1 is minus 3 du. And that's how I got that. That's how I got there. Okay, I just multiplied it. Now, next question. The next question is, what do you think you want to do with that? What do you think? Got to be something we already know how to do. What's that thing in the denominator? It's a quadratic, isn't it? What's the first thing you're going to try with a quadratic? Factor it. I heard it, I think. Factor it. Let's try to factor it. Okay? Now, if I can't factor it, I have to go back to that other miscellaneous thing I did. But I think this one will factor. I think most of them you'll have here will factor. So that's going to be equal to, that's going to be equal to 2 over, that'll be 3u and a u. And I need a 8 in the middle. So I'm going to put a 1 and a 3 here. And I need a plus 8 in there. So I'm going to do this and this. Okay, now, talk to me and tell me what method I'm going to use on that.
Partial.
Partial fraction, exactly. I'm going to write a over 3u minus 1 and b over u plus 3. And I'm going to do partial fractions. Let's see if I got it. Oh man, I'm lazy. I didn't write it down. Okay, here's what it's going to look like. So I'm going to multiply both sides by the common denominator. So I get 2. I get 2. The 3u minus 1s will cancel out. So I get a times u plus 3. Then I'll get b times 3u minus 1. That's a b. And now I think I can find out what things are. Remember what the easy way to do this was? Pick a u that'll make things disappear. What you want to pick u to be here, guys?
-3.
All right, let's do u equal -3. If u is -3, that drops out. I get 2 equal b times -3 here will be -9 minus 1 will be -10. Put in -3 there. Don't let me make any mistakes. So that's a 2. So b is -5. That's good news. What's the next thing you want u to be? That's a little uglier. What about the next one? I need to make that drop out. So I need to make that right there drop out. So what am I going to do?
How do you get -5?
Good question. See it? How about, what should I get? You tell me what I should get, because you're right.
-2 tenths.
Negative 2/10, which is negative 1/5. I was upside down on it. There we go. I'm better. Thank you. Okay, y'all are doing good. You're correcting me. Okay, so what should I let you be next?
1/3.
1/3. So u equal 1/3. That means 2. That'll drop out. That will drop out. If I put in 1/3 right here, it'll be 10/3. So a times 10/3. Invert and multiply. That says a is 6/10 or 3/5. A is 3/5. So here's the answer. My a was 3/5 over 3u minus 1. My b was minus 1/5 over u plus 3. How about that, guys? How are you going to integrate that? Can you tell me what they're going to be? They're pretty easy, actually. What are they going to be?
One's a natural log.
One's a natural log. Okay, now let's be careful with this one though. It'll be the natural log of 3u minus 1, but because that's 3u minus 1 and just not u minus 1. Normally, if we were differentiating a log, we'd multiply by 3, but here we're going to divide by 3. So that takes care of that one. It's sort of another substitution. Minus 1/5 times the natural log of u plus 3. I'm almost finished. What do I do next? Those 3's cancel, by the way. What do I do next?
Plug in for u.
Put in u. So it's going to be 1/5 natural log. I completely forgot what u. Oh boy, let's go. We're gonna have to go way back to find out what u was, or to find out. Oh, I know. We said we were gonna let u be the reason. Y'all don't really know why this is true, but this assumes that u is tangent x over 2. I'm gonna go back and show you where I said that. In the theorem up here, it's tangent where u is tangent x over 2. So I'm gonna that's what I'm gonna put back in. Tangent x over 2 minus 1/5 log of tangent x over 2. I don't even know what that last one was. Plus 5. Was it mine? It was u plus 3. That's a plus. Is u? That's a 3. Plus 3. And that's plus c. I'm sorry I got so messy at the end, guys. But that's the thing you're going to plug in for u with this substitution. Okay. Here's what I want you to do on this bottom part right here. Look at these. These are all miscellaneous substitutions. Decide what you think you want to do with them. And the first thing we do tomorrow will be just to come back and try to work some of these problems. And then we're just going to start on a general review of integrals. I'm going to throw them out. You're going to tell me what to do. Hey, Tiara, have you got a book yet? You know how, or do I need to copy those pages, or are you okay?
No, I'm fine.
You fine? You sure? Okay. Because I looked up these books online and they're really cheap, but you don't want to pay any money you don't have to. Okay? All right. Okay, is everybody good? I should not have to make you log in anymore like that. I hope this works. And I'll see you tomorrow at 1. Look for an email from me just in case I've got an emergency down at the coast, and I'm going to try to get it taken care of from Winston-Salem. But if I can't, I may be logging on from God knows where tomorrow. I don't know. You may see me with a background sitting on the beach. I don't know. But I'm going to try to log on and we'll do it from there, okay? This thing at least means I can go anywhere I want to and log on as long as I have internet. And I don't know if I have internet on the beach or not. Never mind about the beach. Okay. So is everybody okay for the day?
Question.
All right. What's your question, Alexis?
So why did we say that it was tangent? Like,
If that's the substitution that makes this thing work, it's tangent of x over 2.
Is it because there was a 2 in the
And by the
numerator?
way, wait just a second. Let me correct one thing. It was 3u. This one was 3u minus 1. That's what was from right there. I just saw that error. It's just the thing that makes it work. You can go read the proof in the book before that, but if you make that substitution, you can make all these sines and cosines look like what the substitution said they did. It's a trig proof. It's a trig identity proof is what it is. But if you make these substitutions, in the end, you will always be that thing right there, okay? So try it. There were just a couple of those. And by the way, again, if you see a tangent, you need to change it to sines and cosines because those are all the things you have right there, okay? That answer your question, Alexis? What I'm going to tell you.
Oh, I keep forgetting. Okay, we started. Okay, I see. For some odd reason, I thought this was a whole new problem. I'm good.
No, that's that whole problem right there, okay? And guys, some of these problems do lapse into things you already know, so it's just an extra layer of things to do. But we'll work on a lot of them tomorrow, okay? And I will see you tomorrow, and I'll have as many minutes as I want, which I won't take up more than your time than an hour, okay? I try to promise that. I didn't do that today because I got all messed up. But anyway, have a good evening, and I'll talk to you later, okay?
All right.
Bye.
Wait,
What? What you want?
I need to see the very first page of this
Okay.
entire document.
I'm gonna put it. Okay, I'll put it up there. I'm also gonna put it on. I'm gonna put a YouTube link. And by the way, guys, the YouTube link will be in 2 pieces because we had to do the meeting in 2 pieces. But everybody got this last part. But let me show Tiara. Anybody that wants to log out can go ahead and log out. Let me show Tiara the first page. This was that review problem, Tiara, that I did. It was completing the square. Did you weren't in class that day, were you?
No,
Okay. So do you want me to explain to you what's going on here?
please.
Yes, ma'am. Okay. So what happens is sometimes we get these what are called quadratic forms where we get a quadratic in the denominator. Now, if I can factor that, I will. And when I factor it, I can use partial fractions on it, just like I factored that one a minute ago, okay? But this one can't be factored. So here's what's gonna happen. We're gonna make this change forms. We're gonna, first of all, move that 13 out of the way. It's still down there, but we're gonna move it out of the way. And then we're gonna complete the square on these last 2 terms, these first 2 terms. And it's just a cookbook recipe for making a perfect square. And here's what you do. You take half of the coefficient on x, which is 3, or minus 3. You take the sign along with it. Square it, and you get 9. What you want to do at that point is add a 9. Well, you got all this space here, so add a 9 to make that a perfect square, and you'll see how it does that in a minute. But at the same time, take away a 9, because you can't change the problem. So the end result of 9 minus 9 is I hadn't really changed the problem, but I've changed its form. So here's what I do. After that point, I group these together, and they will factor into a perfect square. And the perfect square will always be x, whatever you got when you half that. X minus 3 squared. Look at it. It's x squared minus 6x plus 9. Add these last 2 together. You're always going to add the one to this one and subtract the one that goes with that 13. Now you're going to bring your 13 back into the picture. 13 minus 9 is 4. Okay, I'm going to stop right there for a second. Are you okay with just, it's a manipulation that writes it in a different form that's going to help us out. Okay?
Yeah.
Okay, so here's the question. How did that help us out? Notice that this is something squared plus something else squared. That looks like a trig substitution. Looks like a tangent, doesn't it? Because you got something squared plus something else squared. Agree with that?
Yeah.
Okay, so I'm going to keep going. I'm going to make a trig substitution then. I'm going to let this variable thing that's squared, x minus 3, be 2 tangent theta. So x minus 3 is 2 tangent theta. Remember how we let let something be a times something else. My a is 2, I get that.
Mhm.
Now I've written all over this, but I'm going to show you, I'll try to show you what I got. Now I'll take dx, and the derivative of 3 is 0, and the derivative of tangent is secant squared. And now I'll draw my triangle, because the tangent of theta is x minus 3 over 2, and tangent is opposite over
Over adjacent.
adjacent. Yep. And then if I want to find the hypotenuse, I'll use the Pythagorean theorem. And if you notice, it's the same thing we started with, isn't it? It's x squared minus 6x plus 13. It kind of comes back to us like it did on the other trig substitutions. Okay, so here's what I do. I'm going to substitute, I'm going to make all these substitutions using this. So the first thing I'm going to do is put in x. Well, you don't have x directly, but you have x minus 3, so all I'm going to do is add 3 to both sides. So I'm going to put in 3 plus 2 tangent theta. So I just put in 2 tangent theta plus 3 in there, minus 1. My dx was 2 secant squared theta d theta. My x minus 3 was 2 tangent theta. My 2 is 2. It's 2 squared. So now we got to see what we're going to do with this mess. Okay. Now the nice thing about it is that this is 4 tangent squared theta plus 4. I can pull a 4 out, and 1 plus tangent squared is secant squared.
Squared.
Yep. So, and that's nice because now I can cancel that secant squared. It's looking better. It's looking better. Okay. And furthermore, let's go a little further. I'm going to multiply this one back out. Be careful. Don't multiply that 2 times that 2, because that 2 did not hit that 1. This is all in one set of parentheses. So let's just multiply this out and see what happens. 6 plus 4 tangent theta minus 1. And there's a 2, that's still there. There's the secant squared canceled. And now 2 will go into 4 2 times, so I've got a 2 there. Okay? Simplifying a little more, 6 minus 1 is 5. So I get 5 plus 4 tangent theta. I don't want that 2. There's a 2 down there, but I'm going to bring it out as a half. This makes things look better. That's a d theta, in case you're wondering. I ran out of space. Okay, so 1/2, 5 plus 4 tangent theta. That's easy to integrate. The integral of 5 with respect to theta is 5 theta. The integral of tangent, we still got the 4 there, but the integral of tangent is the natural log of secant theta. Those are the things we memorized for the last test. You're in luck. You don't have, you can look it up now. It's in your list of things you should know, okay? Now all I got to do is what? I mean, once I get to this point, I've got it integrated. What do I have to do?
Plug in theta.
Yeah, go back to theta. Now let's talk about what that is. If I go, and that was way back up here. Let me show you something here. Remember where I said tangent theta was x minus 3 over 2? Look at that right there. If I got a naked theta, I need to release that theta from that tangent, so I take an inverse tangent on both sides. So theta is the inverse tangent of x minus 3 over 2. Easy enough. Okay. So when I go back to this, 5, I'll put in 5 inverse tangent of x minus 3 over 2. So that's that first one. Now the next one was 4 log of secant theta. Let's go back to our triangle. Secant theta that's the reciprocal of cosine.
Mm-hmm.
Cosine would be adjacent over hypotenuse. So this thing is hypotenuse over adjacent. Good. So when I go back down here, oh, not that far, I just put in x squared minus 6x plus 13 over 2. And it's 4 times the log of that. I ran out of space. 4 times the log of that. This pen is hard to write with. But you see what I did?
Yeah.
Okay. Just try a couple of those. These are just a few to try. And it's just completing the square and doing that. And then they usually turn into trig substitutions. Okay? All right.
Okay, I got one more question.
Yes, ma'am.
So about the partial fraction stuff.
Mm-hmm. Yeah.
So I'm confused.
You didn't send it to me yet, did you?
No, because I saw it was like a document on Moodle that only had like 3 problems.
Yeah, I know.
And then Alexis sent me one that had 5,
Right.
and I don't know which one I'm supposed
I
to
would
do.
prefer you do the one with 5, because it gives you more examples of how things can work, and I can see if you understand those examples. The one on Moodle was a little easier. It had the 3, and it had some other things on it. But try the one with 5 for me, okay? Do you know how to do? Are you okay with partial fractions? You think?
I mean, I did 3 of them,
Mm-hmm.
but I couldn't get the last 2. I don't know why.
Alexis was having a problem with the last 2 too. I don't actually. You know what? This is weird. I'm not even sure I've got the stupid. Have you got it in front of you?
Yeah.
Let me try something here. I want to see. I can't get you any bigger. I don't even know what the problems were. So, and I hadn't, because I left it at school and they won't let me back in my office again. So, read to me the next to last one. What was it?
It was number 18, which
Okay.
is the integral sign.
Uh-huh.
And then the numerator is 4x cubed
Uh-huh.
minus 3x squared
Yep.
plus 6x
Mm-hmm.
minus 27
Okay.
all over x to the 4th
Uh-huh.
plus 9x squared
Uh-huh.
dx.
dx. Okay. All right. So here's what you want to do. First of all, you check to see that the numerator is power less than the denominator, so you don't have to divide.
Mhm.
Then let me get a page out. Let me see if I can get you to see. Let me see if I can get something back that'll help us see things here.
Okay.
I'm gonna add a page. Crap. I don't know how to add a page. Give me another page. Okay, here we go.
What about the
Okay,
plus sign? Oh,
here we go.
okay.
Let me write this for you. Here's what we're gonna do, and I'll try to get you to set it up. First thing you're gonna do is factor that denominator, x squared over x squared plus 9. And then we got this whole numerator here, okay?
Yeah.
See what I'm doing?
Mm-hmm.
Now I'll set that up so that it looks like this. A over x plus b over x squared. If you have, this is linear. If you can break that down into 2 more, you could get a common denominator of x squared out of both of those. So you have to step up to the power that's the highest, okay? The next piece, if that had been, one more thing. Oh God, what happened?
Can't you use like the back arrow at the top?
Yeah. No. I lost my page. Hang on. Oh, where was I? Oh, it's in point. This one. I had a there we go. Let me see. Okay, I must have hit the erase by mistake. Okay, you got that whole thing, and in the bottom it's factored. It's x squared times x squared plus 9. Okay, that's going to set up as that thing over that is a over x plus b over x squared. Now, if that had been an x cubed, I'd put 1 more plus c over x cubed. Okay, you got to step up to whatever it is. The last one will be cx plus d over x squared plus 9, because that is something you cannot factor. It's called an irreducible quadratic. You have to put cx plus d over it. It's a linear thing there. So now you had that thing in the numerator, which was 4x cubed minus 3x squared plus 6x minus 27. And when I multiply through by this thing, it'll leave me an a, an x, and an x squared plus 9. If I multiply by that thing, it'll leave me, the x squared will be going to leave me with a b and an x squared plus 9. And the last one will be cx plus d times what? It'll cancel the x squared plus 9 and leave me with an x
Squared.
squared, right? Okay, now, here's the thing. There's not much to let x be here that'll drop it out. X equals 0 is the only thing that's going to drop anything out. If you let x equal 0, it will, on this left-hand side, it'll be minus 27. And it'll drop this one out. It'll drop this one out. It'll drop this one out, but it will not drop that one out. So that'll be, if x is 0, it'll be 9b. So what is b? What's b?
3.
Negative 3. Okay, now.
Oh, that's not a negative 9? Oh, that's an equal sign, sorry.
Yeah, sorry. Okay, now that's as much as you can get, and you need more than that because you need A, B, C, and D. So here's what you're going to have to do. Multiply this right-hand side out. It'll be A x cubed plus 9ax plus b x squared plus 9b plus cx cubed. I'm multiplying that, these two out now. Plus cx cubed plus dx squared. Okay, now, listen carefully. This side can only equal that side if the coefficients of the like terms are the same. So look at this. I've got an x cubed here and an x cubed there.
Mm-hmm.
That says a plus c. If I were to add those two together, I get a plus c would have to equal 4 because that's the coefficient on x cubed. So that takes care of those two. What's the only constant in here?
9b. Wait.
All right. So that says 9b would have to be minus 27. Boy, we don't gain anything from that because we already knew that, didn't we?
Yeah.
We knew b was minus 3. The other one, here's an x, 9a. 9a has to equal what? What's the coefficient on x there?
6.
6. So 9a has to equal 6. And finally, b plus d, there's the x squared, has to equal what?
Negative 3?
Yes, yes. B plus d equal negative 3. I'm trying to figure out how I'm going to get another piece of paper in here. All right, okay, so shucks, that ain't it. Add page. Okay, add page. Blah. Okay, hang on. Yay! All right, yay, I did it. Now if I could just remember next time how I did it. Okay, so what we got is this. A plus C is 4. We know that B is minus
3.
3. Is that what it was?
Yeah.
We know that B plus D is minus 3. And we know that A is 2/3 because I divided by that one by 9. Okay?
Oh, okay.
See that? Okay.
Yeah.
So now, if I can find D, because B was minus 3. Well, if B was minus 3, what's that tell me about D?
You know.
Add 3 to both sides. D's got to be 0.
That's what I said.
See it?
Mm-hmm.
Okay. So I know that one. I know that one. I know B. The only one I have to find now is C. And look at this. I knew that A plus C had to equal 4.
Oh, we know A is 2/3.
Yes. Yay. You know what? I'm not absolutely sure I haven't made a careless error, but that's the way you do it. So that means C is 4 minus 2/3. That's 12/3. C is 10/3. So now you got all the things you need. I'm sure that I will work this one again tomorrow because this is exactly the one, Tiara, had the question about.
I am Tiara, but I understand.
I mean, Alexis, I'm sorry, Alexis and Tiara. So my B was -3, A, B, C, D was 0. I go all the way back up to whatever the thing it was. Okay, you put in your A, put in your A, put in your B. Your D was 0. So put in your C. This will be nice because this will just be a natural log. Notice you got an x squared plus 9 and an x up there. And these will just be power rules. That's how it works.
Okay, I have one question
Yes,
because this is where I messed up. So
Mhm.
you see the b over x squared.
Mm-hmm.
Why is it not like bx plus
Because it's
c?
not an irreducible quadratic.
So that's
It's
the only time.
it can be broken down. X can be broken down into 2 linear things. And if it's 2 linear things, it still stays a constant. Okay. The reason this has to have cx plus d is because you can't factor it. This one you can break down into linear factors. Now, if this had been x squared minus 9,
Yeah.
you could have put
Oh.
x minus 3 and x plus 3, and then those would have been constants. I mean, up here too. But if it's what we call this irreducible quadratic, that's the only time you use that. Let me show you one other thing. So here's the deal. If I had something like this, if I had something with an x minus 2 cubed in it, that's 3 linear factors, okay? Because it could be broken down like that. The way I would set that up would be a over x minus 1 or 2 plus b over x minus 2 squared plus c over x minus 2 cubed. If it is a linear factor that you can break into pieces, you'll just step up to whatever, how many pieces it is. Okay. The reason for that is because that's what would give you that common denominator. I mean, you pick the most that appear in any one thing, but we could have this, this, and this. So for example, 1 over x and 1 over x squared and 1 over x cubed, what would their common denominator be, Tiara?
X cubed.
So you need all 3 of those.
Okay, well, that's where I've been making my error.
Okay,
Like,
good.
I did that with the next problem too.
Okay, try to see if you, what was the next problem? Tell me so I'd be ready for it. This one was 18. What was the other one?
Number 22.
22. Okay,
Uh,
I'll try to have these solutions done tomorrow. And everybody, I want you to send me what you've got so I can look at what people did and see what their errors are. So I know what your error is now, but send it, try to see if you can fix it and send it to me, okay?
Okay, hold on. Wait, so this says x squared plus 1 cubed. So,
Okay, here's
this
another,
is-
okay, that's a good point. Good question, look at this. That's irreducible cube, look at this. If you have that, you can't break that down because it's a quadratic. It's gonna look like ax plus b over x squared plus 1 plus cx plus d over x squared plus, oh crap, sorry, jeez.
oh, you're fine.
It moves on me when when my hand hits it. That's gonna be x squared plus 1 squared. And the next one will be ex plus f over x squared plus 1 cubed. That's because you can't factor x squared plus 1. But
Okay,
it still works. You still have to step up to the highest power. And you have to use ax plus b, cx plus d, and ex plus f. Did I really give you all that problem? Wow.
yes,
It's not really that bad because some things cancel out, I think.
Cancel out. Like, maybe my algebra, something's
Well,
wrong in here.
Look,
but
when you multiply through by x minus x plus 2, x plus 1 cubed, one of those will cancel out with that. 2 of those will cancel out. 3 of those will cancel there. Was there any other factor down below?
no, it's just
Was there, after you factored it, was there any x plus 1 or x minus 1 or whatever?
no.
Okay, then that's what you need to do. Clear it out, and then set your coefficients equal to each other and whatever's on the top. I don't know, whatever's on the top. do what I did. Try. You can't make anything drop out. You cannot use that Heaviside method here.
Yeah, I see.
You're going to have to just match your coefficients like we did in the last one.
Okay.
That seem better?
Yeah.
Okay. Try it and send it to me, okay? And then I'll look at it, and we'll work these together tomorrow, because that's what I want to do. I just want to work integrals tomorrow, so whatever y'all are having trouble with, okay?
Okay.
Okay. All right, you got any more classes today?
Well, I'm not sure if I actually have to show up to genetics, so I don't know.
Well, because it's going to be a PowerPoint.
Yeah, but she also sent out a group chat for something, and I'm like, do I actually have to go to this? But I don't
Yeah,
know.
well, I guess if you want to chat with anybody about genetics, I don't know.
I mean, I don't have much to say. She assigned so many assignments. I don't see how we're supposed to go on this chat and then do everything by 7:20 tonight.
Well,
I don't know.
okay. Well, I should let you go, and you should get on that stuff, okay? Because I mean, if you see something I don't understand this concept, just that's your chat, okay? That's how she's
Yeah.
That's how you're telling her what you're telling me right now, okay? So I don't know.
That's what it seems like. I hope so.
Yeah, that's probably what it is. So,
But thank you.
all right. I'll see you tomorrow then, okay?
Okay.
All right. Bye.
Bye.